So I hope you're taking some time to realize that radicals and rational exponents are the same thing, just written in a different form. So that's what this whole next page is over. It's just making sure we can go back and forth between the two. So the first thing says represent as a radical with a smaller root index. All that means is they want this index to possibly not be a 6. Can it be smaller? So what we're going to try and do is rewrite this in a form that's a rational exponent. So we do power divided by index. So y to the 2 6 and z to the 4 6. Again, power divided by index. Well, y to the 2 6 is really just y to the 1/3, and 4 6 reduces to 2/3. So now we see that our index is a 3, with this being a power 1 and z having a power of 2. So this is the cubed root of y to the first, which we don't need to put the 1, and z squared. So we get the cubed root of yz squared. Now it looks like on number 2 we're stuck. 6 root of 25. Well, doesn't look like we can do anything because 25 has a power 1. But what is a way to rewrite 25? Well, 25 could be 5 squared. Now we can rewrite it as 5 to the 2 6, and 2 6 reduces to 1/3. So the 6th root of 25 is really just the cubed root of 5. So in this next one, again, it says perform the indicated operation. Well, they give you radicals, and we're going to learn in the next section that if we want to multiply radicals, we have to make sure we have the same index, and we do not. Since we don't have the same index, we're stuck in radical form, but we can change it into exponential form. So if we change it into fractional exponents, we have x to the 1/4 and x to the 2/3. So we change them into rational exponents. Well, now we know we can use rules of exponents. When we multiply, we add powers. So we need to take 1/4 plus 2/3. Well, to add fractions, we have to have a common denominator. So the first number that 4 and 3 can both go into is 12. So this needs to become a 12, and that needs to become a 12. 4 times 3 is 12, so 1 times 3 is 3. 3 times 4 is 12, so 4 times 2 is 8. So I end up with x to the 11/12. But because it was in radical form, it didn't say it wanted fractional exponents. We need to go back into radical form. So the 12th root of x to the 11th. So now we have the 5th root of x to the 4th times the cubed root of x squared. Again, we're stuck in radical form because we don't have the same index. So we'll put them in rational exponent form. So x to the 4/5 times x to the 2/3. Again, we need to find a common denominator. So this is going to be a 15 and a 15. So 5 times 3 is 15. So 4 times 3 is 12. 3 times 5 is 15. So 5 times 2 is 10. So we end up with x to the 22nd over 15. That can't be reduced, but we can put it back into radicals, and we need to because it did not say rational exponents. So this is going to be the 15th root of x to the 22nd. Now we haven't come to the point where the number with the power on the inside is bigger than the index. So I'm going to put a dot, 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 because we really are not going to stop there once we learn what to do in the next section. So in number 3, again, we are stuck in radical form because we don't have the same index. So we're going to change them into fractional exponents. X to the 4/3 divided by x to the 2/4. The first number that 3 and 4 could both go into is 12, and we're going to subtract exponents. So we need to do a denominator of 12 for both of those. So we need to multiply by 4 here, so 4 times 4 is 16. And we multiply this one by 3, so 2 times 3 is 6. So we get 16/12 minus 6/12, again, because when we're dividing, we subtract exponents. So 16 minus 6 is 10, so we end up with x to the 10 over 12. That can be reduced by 2, and so we end up with x to the 5/6. And then putting it back into radical form, we get the 6th root of x to the 5th. Putting it back in radical form because we had radicals to begin with. So lastly, number 4, we had the square root of we have to rewrite it in fractional exponents. So 5 to the 1/2 times 2 to the 1/3. What are we going to do there? They don't have the same base. If we don't have the same base, we can't do anything. So we're actually done at this point. Don't try and multiply 5 times 2. You can't do it. The only time you can multiply with fractional exponents or rational exponents is you have to have the same base so you can add the powers. So be careful. You are done. You can't do anything with that problem. So make sure you know when you can go farther and when you can't. So last one, write as a single radical. You see you have a double radical. We don't really like double radicals. So let's start with the innermost radical first. The 5th root of m. Well, m has a power 1, so that'd be m to the 1/5. And it's still under the cubed root, and the cubed root power is a 1/3. And so now we need to just multiply power times power. So we get m to the 1/15. And then we're going to put that back into radical form because it said write as a single radical. So this is the 15th root of m. I know some of y'all just want to multiply 3 times 5. Don't do that. You need to put it into rational exponents. With rational exponents, we're allowed to multiply exponents. You're not just allowed to multiply indexes.